Okay, ready?
Do you G-sharp?
Hi, I'm Alan. So my name is Alan.
He's a young guy that is still tries to code in C and C++. But,
let me do the intro, because I think this deserves an intro. Alan McGovern was this guy. We're doing Google Summer of Code.
Isn't he carrying coffees or something?
No.
Coffee machine?
So Alan McGovern, we had a Google Summer of Code, and I really wanted to have a BitTorrent library in C#. And the reason I wanted this is because I figured, you know what, instead of doing HTTP fetches and downloading files like that, we really should be using BitTorrent. BitTorrent should be a fundamental component of every application that needs to transfer files instead of FTP or fetching file synchronous. That's just stupid. But we do need a library for that. So in the Summer of Code, we said, all right, we need a student that over the summer writes a BitTorrent library. How hard can it be?
Very.
And that year, we received 3 applications, I think? There were 3.
I think so, yeah.
But Alan was the first one. Alan submitted an application, and he immediately contacted me on IRC and said, well, I've been thinking about this. I think this is how I would build it, et cetera, et cetera. So we basically said, well, Alan seems to be like the most excited guy for the BitTorrent library. So we got Alan on board, and he did an amazing job over 2 months. Unbelievable work. But not only that, Alan kept working on this in his spare time. So next year, we brought him to Boston to work on other stuff that was not BitTorrent.
Yep.
And he's an amazing hacker. And 1 year after when he graduated, we said, you need to work for us. So that is the amazing Alan McGovern, one of the best hackers in the world.
Thank you. So the idea of this talk isn't really to talk about how MonoTorrent evolved. It's basically there are a few problems that I encountered while implementing the BitTorrent specification. I just want to show people how I worked around them or how I came up with a solution. So basically, what is MonoTorrent?
you need to use the wire.
Oh, sorry. Do I have to turn it on? Or? Hello? I don't know. Okay. Okay. So, what is MonoTorrent? It's just a .NET-based BitTorrent library. And it's just a bit of background info here. So it started out in the 2006 Google Summer of Code. So as Miguel said, like it was 3 months, I think, 10 weeks. And of course, I didn't have everything. Like there wasn't 38,000 lines of code written then. But these days, it's about 38,000 lines of code. It supports pretty much everything you want from BitTorrent library. Like multi-threading, UDP trackers, HTTP trackers, all the different extensions like DHT, which is like an alternative to normal BitTorrent trackers. So basically you can find other peers without having a centralized server. So basically making BitTorrent decentralized. So everything is supported. So as I was saying, the idea behind this talk is 2 areas. One, the threading. How did I implement the threading? So as you can imagine, there's 60 connections, so 60 sockets. You have to do a lot of like disk I/O, reading and writing to disk. You have to contact trackers. It's all asynchronous. You can't afford to do blocking operations because it'll just kill the performance of the library. You want to be able to download at 10 megabits a second or 100 megabits a second. You can't do blocking APIs. And the other bit, I want to talk about the algorithm which allows you to choose who you download a piece of. As in, maybe piece 1 off this guy, piece 2 off this guy, or maybe you split it between different people to get a single piece faster. So that's kind of interesting, just how it all works. So that's what I'm going to talk about. So the common thing I see like a lot on the internet is people want to use threads. And like, oh, I have to download this file, I want to use a thread, and then I want to update my UI from the thread, and then I want to do this from the thread. It's all wrong. Like you shouldn't, that's the wrong way to use threads. Threads aren't a way of updating your GUI and doing this and doing this. It just won't work. You're going to end up with deadlocks, things are going to break. So what's the ideal number of threads in an application? Say you have a lot of work to do and you can make a parallel. Anyone want to hazard a guess?
Number of GPUs?
1.
If you have 2 CPUs, you need 2 threads.
But you can deadlock. Which is better, doing the work slowly or not doing any work?
So
That's just wrong.
I'll come back to this later. The idea is, with one thread, you will always complete your work. It could be slow, but it will always be completed. Because otherwise, if you have two threads, you can deadlock. So this is. I'm going to come back to these questions now later. So how many other threads should one thread know about?
0.
Yeah, exactly 0. Because if your thread is waiting on another thread to finish, you don't need threads. It needs to be like that's serial. Threads and serial don't work together. They should be parallel. So yeah, just 0. And how many locks or mutexes should you need to access shared data? Like how many layers of locks? Well,
Well, it depends on the number.
ideally 0, because there should be no shared data, because otherwise you can't make it fully parallel if you're sharing data. But of course, we live in the real world, so we do actually need locks because we will have shared data in some cases. So in that case, 1. Because if you have more than one lock, if you have 2 locks, different threads can acquire the locks in different orders, and you'll end up with a deadlock. So that's what I was saying about the one thread. You don't want 2 locks, or if you have 5 locks, then it's going to break. There's no way you can guarantee that your application is always going to take the locks in the correct order. Well, if you can guarantee that, then why are you using 5 locks? So really you want 1 lock. So just to remind you, if you're trying to use threads to do too much stuff, like when using lots of locks, you're doing it wrong. It's the wrong way to use threading. So for MonoTorrent, what we have in a typical case is maybe 60 connections. Each of those is transferring data. Then you have lots of very slow disk access. So if you're downloading data, you're going to be writing 16 kilobytes at a time. So if you're downloading at a megabyte a second, that could be 30 or 40 write calls a second. You have web requests, because you need to contact servers. And you have the DHT requests, which is like the decentralized peer selection. So all of this is very slow. You can't afford to use 1 thread per socket, or 1 thread for disk I/O, or 1 thread for each web request, because it's too many threads. You're going to end up with 200 threads, 300 threads. It doesn't scale. And you can't use blocking calls, because you can't just go socket.read and then wait for the data to arrive, because what are all your other sockets going to do? They're going to sit there with data pending, and you can't read it because you're waiting for the first socket to give you data. So blocking calls don't scale. So the original architecture that MonoTorrent used was basically locks and threads, which what I said is very bad, and this is why. When a peer connection starts, it receives some data. Of course, we just receive this block of information. What it then did is, I took a lock. So on the peer, I took a lock. So then I could use this data, I could decode it into proper data, and then I could update that peer state. Because sometimes I just had to change a flag, like make it a Boolean true instead of false. So in that case, I don't need to access the actual core. So you think, okay, this is good. I'm using a very small bit of information. I just need to update the peer, so I just lock on the peer. But sometimes you also need to update the core, like the engine. So you take a lock on the engine, and then you update it. So that's good. We have 2 locks. It's very simple. Sometimes you just need to update the peer, sometimes the peer and the engine. Then of course, you have 60 people doing that. So this makes sense. You're always guaranteed that the peer will be locked and then the engine. That's the order. So lock A, then lock B. But there's problems with that, and this is one of the problems that I was fighting with for maybe a year, is that essentially the engine will always, like, you need a loop. Like the engine sometimes needs to just do an operation. So the engine will lock on itself, and then the engine will realize, oh, there's a peer, and this person hasn't sent me data in 2 minutes, so I need to close that connection. So, oh, I came up a bit wrong. So then the engine is now locking on the peer, but that's backwards. So what basically happens is that the engine would deadlock, and there's no way around. There's no easy way to fix this. I'd fix one case and it would break somewhere else when I implement a new feature. So basically, 2 locks was too hard. I can't do 2 locks. It just blew up. So that's what I'm saying. two locks, you think it's easy, but then there eventually comes to a case where you can't do it with two locks. It's too hard. So I decided what I need is a new architecture, one without locks. I need a new API. So basically, it uses one thread. There is basically like a main loop in a GTK application or a WinForms application. Everything happens on the main loop. So what happens is I have one thread which executes all the engine logic, which does all the data decoding, the data, like the updating of the peers, and every call is asynchronous. So you're thinking, okay, one thread, how are you going to handle 60 sockets? Well, each socket, just use the normal asynchronous APIs, like begin, receive, end, receive. But instead of actually doing processing on the thread, it always proxies back to the main loop. So this is essentially what the code looks like. I just call a standard socket.begin connect. Then, forgot about that. So like if you're familiar with the socket APIs, begin connect is the regular call. So once the connection attempt is finished, .NET will invoke this callback, which is here. And all I do is I queue that up on the main loop and then do the normal stuff here. So as you see, I'm using like a Lambda, like just anonymous delegates, because it's a very easy way to proxy objects and code onto the main loop. So every asynchronous call essentially just does this. So rather than having to worry about, oh, I have to lock on this and then lock on this and then do my updates, everything goes to the main loop. So the slow processing is actually receiving the data or writing the data. So all of that is asynchronous. But from my application's point of view, there's only one thread, this. So sure, MonoTorrent is using maybe 10 or 12 threads, but all I really work with is one. So because I only have one thread that I actually work with, I can't deadlock, and I can never take a lock in the wrong order. And all the slow work isn't done. No slow work happens here, so the performance is really high. Some people use the library and they've reported that they can saturate a 100 megabit connection, like on their LAN, using MonoTorrent, which is quite nice, because you think, okay, one thread, it must be really slow, but it's just one your core logic. So everything is still fast. You can't deadlock because there's no locks. I don't use a lock except for small parts. And in that case, there is only one lock, because here, when you're queuing it up, this has to be protected by a lock, but only the queuing and dequeuing from the main loop is protected. I don't need to protect anything else.
This is a great architecture if your application is I/O bound.
Mm-hmm.
But if you're CPU bound, then...
If you're CPU bound, yeah, it's a different story. So it just depends. Well, yes and no. If you're CPU bound, you can still use this. You just go, instead of socket.begin connect, you'll go, my big long operation that takes 10 seconds, .begin. And your 10-second operation will be in the background thread from the thread pool. And then once that 10-second operation is finished, you go back to your main loop and you do a microsecond of work. So that's what I'm saying.
Then you're explicitly using multiple threads again, because then your computation is running another thread and you have to really do.
So but then again, you're back down to your operations. It's like, can my operation be parallelized? And if so, well, actually, there's another talk about that kind of stuff later by Jeremy Lavelle, who's around there. So he's going to talk about how to do that kind of work without using threads. You know, like without explicitly starting, I need 4 threads here to do this work. He'll show you how to do it without using threads explicitly.
That way of saying it,
you're not explicitly using threads. Yes.
You're not explicitly creating new threads.
And that's the point.
Explicitly create a thread.
Mm-hmm.
Create a thread.
I think that what he's saying is you don't want to touch any shared state on the thread. So what he's doing is he's not touching any shared state because he's using threads there.
Mm-hmm. It's all in the background.
Yeah.
Is the thing.
But he's not sharing any state, and the only state that he needs to protect is the state of the queue.
Mm-hmm.
And the question is, can we? I mean, I think that Parallel Frameworks has a non-locking queue implementation now, right? Which would be even more fantastic. But anyway.
Yeah. So it's just basically a way of using threads without worrying about locking or any race conditions because all the important stuff happens on one. Like all the important non-blocking, really short-lived tasks happen on one thread. So that's basically how MonoTorrent works on threads. So it's quite, I like to think it's a lot simpler than before, because before I'd fix a bug with a deadlock, and now I haven't had a deadlock in more than a year. So it is working much better. But yeah, as you were saying, different applications do need different approaches. For this kind of application, I think it's perfect because the only slow stuff is disk access, is socket access, is web access, and that can all be handled with the normal calls. I never have to explicitly use threads or worry about it. So the second half of the talk is about the piece picking. Basically, in BitTorrent, when you download a file, it'll be split up into small chunks, maybe 32 kilobytes up to 2 megabytes per chunk. So, into pieces of 32 kilobytes to 2 megabytes. And then each piece is in chunks of 16 kilobytes, which is specified in the protocol. So if there's 32 kilobytes, a 32 kilobyte piece has 2 chunks. A 2 megabyte piece would have lots of chunks. So the idea is that sometimes if you have really big pieces like 2 megabytes or 4 megabytes, you don't want to have to download that off one person. Because if you're downloading 2 megabytes off one person and they're really slow, then you're going to wait forever for that piece to arrive. But you don't want to. There are also some other things. Sorry. There we go. There are other conditions as well, because you don't want everyone to start downloading from the very start of the file and download in order. Because then if someone goes offline, you'll find that everyone has pieces 1 to 50, no one has pieces 51 to 100. So you have to be you have to choose the rare pieces. Also, you don't want everyone choosing the same rare pieces, because there's no point in everyone going, oh, only one person has piece 7, so everyone downloads piece 7. That's bad. So it has to be kind of random. So you go, okay, I have 10 pieces, they're all kind of rare, I'll download one of those. And then of course, sometimes you don't want to download files. There could be 100 files in the torrent, you want one. So all these make it more complex to pick a piece, because you have to follow all these rules. And then there are some extensions to the protocol which say, under certain conditions, you're allowed to choose this, otherwise you're not. So I needed a way of solving this, which was one I could test. Because I do have a lot of NUnit tests, because without them, I'd never get anywhere. I'd fix a bug, I'd break something. So what I originally started with was one class. So I just have a class, and it's called piece picker. And it just picked a piece at random. And then I made another method in this class, which made it choose rare pieces at random. And then I made another method in this class. I made it more complex. And it's like, now it can ignore some pieces. And then I had to add more code and more code. And as time went on, I couldn't test it. It was impossible for me to write a test and verify that under every condition, I will actually choose a piece randomly. Or under every condition, I'll choose one of the rare pieces. It was too hard. And there's too much code, too many branches. There's no way I could test everything. So what I really wanted was one class which will select at random. Well, this isn't working at all. One class which will choose rare pieces. Sorry about that. One class which will be able to let me ignore pieces. Ignore files. And then other classes then for specific behaviors. So I wanted one class to handle each kind of picking behavior, and then I wanted to chain them into a pipeline. So, code time. Give me a second now to see if this will work again. Yes. Okay, so as I was saying, I originally started with just one class, piece picker, which had everything. I figured that couldn't work. I need different subclasses. So this is the standard class. There are basically 2 important methods. This one here, pick piece.
Oh yeah, you switch the display to confirm it.
Okay. Da-da-da. Keep that. Okay, so the two important messages I'm going to talk about are pick piece and is interesting. So pick piece, as it says, is just a way of, that's the method that's called when I want to choose a piece from someone. And then is interesting is the method that tells me if a particular person has a piece I want. So are they interesting to me? Do I want to go through all this complex calculation and choose a piece from them? So the idea behind the class was when you're implementing a subclass for specific behaviors, you don't want to implement, you see all these virtual methods? You don't want to implement all of those. You only want to implement one, maybe two. So the way it works is when you create a piece picker, you basically, it's a pipeline. So you make a piece picker which wraps another one, which wraps another one, which wraps another one. And the default implementations of all these methods just, sorry, here we go. All it does is it returns I have the picker up here, and I just call a method on that picker if it's not null. So it's really simple. By default, I will always call the base implementation, the class I'm wrapping. So what it means is you can write code like this. This is an entire subclass which does randomized picking. That's all, just one method. Because every other method will automatically call the one I've wrapped. So basically there must be one class which implements everything, but everything else just has to change one specific piece of behavior. So for random picking, all you do is, is that font big enough? Or do I need to make the font bigger? Is the font size okay? Okay, so for random picking, all I do is I choose an index between the start and end of the interesting range, and then try and pick a piece there. If I can't pick a piece between the midpoint and end index, I choose it between the start and midpoint. So it's very simple. That's how you do random picking. This is very easy to test. It's just 5 lines of code. You could test that in your head. So this is the advantage of this new method now, because I can test things really easily. Or if you want to ignore something. Suppose like you never want to download a piece you already have. So one of the things is I need to be able to ignore the pieces I already have. So all I do is this bit field is the pieces that the remote peer has. Like that one is all the pieces I want to get, and this is all the pieces I already have. So it's just a bit field operation, like a NAND, like not and. So it's just one operation to remove all the pieces I already have from this list. So if what I have is I have these pieces, so it's just a normal bit field, and the remote peer has this, all I end up with is 0, 1, 1, 0, 0, 0, I think. So I'll have 2 pieces left. So this is really easy to test again. It's 2 lines of code. So before it was very complex because I had one class trying to do everything, but now I have a much simpler method of doing everything. And that is mostly my talk. So back to here, and let's come back to the start. So basically, does anyone have questions on anything I've spoken about? Questions?
Do you still have the beautiful Persis version running?
I'm going to say yes, because you'll forget about it by the time you leave. I'm going to say yes because you'll have forgotten by the time you leave, so you won't check. I think it still works, but I don't use it. Like, I haven't used it in a while.
What?
So, sorry. I use Monsoon. It's better.
Are there many users? that many programs?
There are a few, like there's a few open source ones. There's Monsoon, there's another one, Parrot BitTorrent or something. There's a guy who's made, it's a little application. He was on the IRC channel a while ago. It's basically, it will take a video file. Like suppose you make a game, you record a screen capture from it, and he basically has a little application which will generate a torrent, will like strip information from it, add it to the torrent, and then distribute it all automatically. So you select a file, you just hit upload to the internet, and he uses MonoTorrent to generate everything, and then put the file on the internet and publish it. There is an extension for Banshee, because MonoTorrent has, like this library has been exposed over dbus. Well, there is a library which will, like an application which exposes this over dbus. So Banshee can then download podcasts which are via torrent. Okay, that extension isn't really maintained because I don't have the time for it. But there is an extension out there which will allow you to download podcast torrents. There are a few like commercial companies which have contacted me in the past, which use MonoTorrent to distribute files like updaters for games, or one particular company, they do it's basically VM image migration, and they want to be able to have one VM image and then migrate that to 200 servers. And they're using MonoTorrent for that because it allows them to have one centralized location, and then every computer can transfer the data between themselves. So there's no single bottleneck. It's not like 200 computers trying to get all the data off one server. They have normal BitTorrent. So it makes their deployment much, much faster.
What's the license?
It's MIT X11, so as open as you want.
There are some initiatives to extend the BitTorrent protocol to stream video or something like that.
It's funny you should say that, because we have the sliding window picker, which basically a guy came and got in touch with me and was like, I want to use BitTorrent for streaming. Every 2 months someone emails me and goes, can I talk to you? I want to stream video with BitTorrent, and I want to use MonoTorrent for this. So the idea behind the sliding window picker is that when you're streaming something, you want a buffer of maybe a minute. So you want to download these specific pieces very quickly. And then there's another bit, say from 1 minute to 3 minutes, where you want them, but it's not urgent. And then finally, anything else you can choose whenever you want. So if you have all the high priority pieces and all the medium priority pieces, everything from where you are in the video file onwards is low priority. So you just choose it whenever. So all you really need to do with MonoTorrent is keep the high priority start index updated. So as your video player plays the file, you go, okay, I've played the first 10 kilobytes, you increase the index by 1. You've played 100 kilobytes, increase the index by 10. And MonoTorrent will then automatically only select the pieces from that point onwards, and will always keep a buffer of a minute. So it is possible to stream via BitTorrent, but it isn't ideal. But it can be made better. Because the advantage of BitTorrent is that anyone can choose a piece off anyone else, but if you're streaming, maybe 2 or 3 people will have the piece and then you'll need it, and then nobody needs it because it's in the past. People just want new files. So it's not ideal because you don't get the same kind of bandwidth sharing that you would in a normal torrent. But yeah, it is possible. So
You probably should talk about how this can be plugged into the server-like media pipeline.
yeah, so
1 minute. 1 minute.
1 minute, okay. So yeah, this is a fully managed library. It's all C#, so it's fully compatible. Like it can be run inside the Silverlight sandbox. So if you really want, you can develop a little BitTorrent client which will publish the Silverlight. Like Silverlight can only access a limited set of ports, and in those limited set of ports, there's an authentication limits on. I can't remember the words now, but basically you have to respond with a certain bit of data before you're allowed to make a connection. So you can't just connect to anything. You have to connect to a proper service, like a Silverlight service. So you could write a quick application using MonoTorrent to expose BitTorrent over the Silverlight service, and you can then just use this to stream video in your Silverlight application. So if you want video streaming in Silverlight, you could do this just as easily.
So, and could you just build that in a MonoTouch application and get fiber loading for iPhone?
Apple have banned BitTorrent from the App Store. So
It has banned BitTorrent.
Yeah,
But if-
but not
if you implemented a downloading program
Yeah.
that didn't explicitly say BitTorrent, that would be okay. But as soon as you use the word BitTorrent, they'll say no, because BitTorrent is illegal, and people only use it to download illegal things.
It's MonoTorrent, so
It's completely different. It only downloads Linux ISOs.
why is it called MonoTorrent?
Because a long story. It was originally called BitSharp because no one was using a name like that, and I figured, BitTorrent, C#, BitSharp, it's great. But there was another library then which had been inactive for 2 years, and then the guy activated again, and he made a commercial product out of his library, and that was called BT Sharp. So BitSharp and BT Sharp, it's too similar. So it just was called MonoTorrent.
What's wrong with Mono, dude?
So
Okay, thanks for listening.